All right, guys, we are on page 22, and we are going to go back through our characteristics, okay, of rational functions. Are y'all with me? Because I am recording. Major, your seat. Let's go. Here we go. I am factoring both my numerator and denominator completely. What two numbers multiply to give me 6 and add to give me -5? -2 and -3. Okay. And then down at the bottom, what two numbers multiply to give me 3, add to give me -4? -3 and -1. Perfect. Okay. So I am taking a look at what I have, and I want to reduce. Okay? What do I have on the top and the bottom that is exactly the same? The x minus 3's. So when this reduces, I have x minus 2 over x minus 1. All right. The very first thing that I'm going to identify are the wholes, if any. Okay? Now, wholes come from what canceled out. So I know that I canceled out the x minus 3's. So if I set it equal to 0 and I solve for x, that is going to give me the x coordinate of the whole. Okay? How do I get the y coordinate? What do I do with 3? Plug it back into the simplified equation. So that's going to be 3 minus 2 over, bless you, 3 minus 1, which is going to give me 1 over 2. That is my only whole, because I only canceled out one of my expressions, okay? Now, what remains in the denominator, okay, what remains in the denominator gives me my vertical asymptotes. I'm going to abbreviate that as VA for vertical asymptote. Okay, so what remains in the denominator there is the factor x minus 1. If I set that equal to 0 and I solve for x, the equation of that vertical asymptote is going to be x equals 1. Done. Okay? Then I want to talk about the horizontal asymptote. Okay? The horizontal asymptote comes from looking at the exponents. Okay? Right here, I have a highest exponent of 2 in the numerator and a highest exponent of 2 in the denominator. If my exponents are the same, what will I do? Something with my coefficients.
Divide the coefficients.
Perfect. I will divide the coefficients. Now, right here, the coefficients are 1 over 1. And my horizontal asymptote has an equation y equals. Right here, 1 over 1 is 1. Okay? And then, lastly, I'm going to identify my x-intercepts. Okay? And that comes from anything that's left over in the numerator. So right here, I have an x minus 2. I set it equal to 0 and I solve for x. We know that the x coordinate is going to be equal to 2, right? But is that the notation that I will write my x-intercepts in? No, because this right here is the equation of a line, okay? I am looking for a specific point, so I will write that as the ordered pair 2, 0. Okay? And that's all I want from that. Okay? All right, let's move to this second one. Can I factor anything on the top? No. What does my denominator factor into? x minus 3, and x plus 2. Perfect. Okay. Does anything cancel? No. So for wholes, I'm going to say none. Okay? For vertical asymptotes, how many do I have? 2. That comes from setting the x minus 3 equal to 0 and the x plus 2 equal to 0. So I have 2 of them. I have x equals negative 2 and x equals 3. Notice I listed those separately because each of those have their own equation. All right, then let's talk horizontal asymptotes. Horizontal asymptotes come from looking at your exponents. There is an understood but unwritten x to the 0 up there in the numerator. So I'm comparing a 0 to the 2. Where is it bigger? At the bottom. So bigger on bottom, that's Bobo. So y equals 0. And that is the equation of what? What moves from left to right? The x-axis, yep. Okay? You weren't wrong. A horizontal asymptote, right? But that is specifically the x-axis. All right, now let's talk about x-intercepts. Do I have any variable on the top? But what is x to the 0 power? I could substitute a 1 in for that. So do I have any variable technically in the numerator? No. There are none. Now, that should make sense, y'all, because wasn't the x-axis my asymptote? So should my graph, or based off of what I have known in the past, is that graph going to touch that asymptote? No. So if it's not going to touch the x-axis, there are no x-intercepts. Okay? You with me? Okay. All right. Let's take a look at this function right here. Okay? And I've got a sketch of the graph. All right? Ooh, that's blurry. I think it's blurry on the paper, but it certainly does not help right here. Now, I want you to kind of take a look at some things. All right? I see a vertical asymptote. I see a horizontal asymptote. I even see a hole. Do you see what I'm talking about with the hole? Right there. It's just kind of like an open location, and my graph just kind of keeps going right on the other side of it. Okay? Let's factor and simplify. So let's start with the numerator. Okay? I'm going to slip and slide. 3 times negative 3 is negative 9. And I need those factors to add to give me a negative 8. What works there? You want them to multiply to give you negative 9 and add to give you negative 8. Negative 9 and positive 1. Good. It's okay. It's Monday. I'll cut you a little bit of slack today. Not on Wednesday, though. You've already had your Monday for the week, okay? You got a holiday tomorrow, so Wednesday will kind of be like a Monday. I didn't make the calendar. Sorry, friends. Next year, that holiday will be on Wednesday because Veterans Day is always November 11th, and that's a government holiday. And since we're a military community, we follow that. Even the government is shut down still. Okay? Keep your phone put away or I'll take it. Huh? I don't know. I'll look that up in a minute. Okay. Uh-huh. Yep. It just follows that calendar. Huh? No, so like there are other counties surrounding us that don't have tomorrow off, but since we are a military community and we serve the base, does that make sense? Okay, all right, here we go. Right here, if I factor this, my numerator is x minus 3 times 3x plus 1. And then the denominator, how does that factor? Perfect. X plus 3, x minus 3. All right, now when I factor and simplify just means cancel out as much as you can, okay? That leaves me with the 3x plus 1 over the x plus 3. All right, this is my simplified expression. So I want to identify the coordinates of the whole. We should know that the x coordinate of the whole is going to be a 3 because I took the x minus 3 and I set it equal to 0. But solving for the y coordinate, I am going to take the 3 and plug it in to my simplified equation. 3 plus 3, or 3 times 3 is 9. So that's going to give me 10 over 4. Well, what does 10 over 4 reduce to? 5 over 2. Now it does look to me like that whole is about halfway between yeah. Oh yeah, thank you. I was like, that's not right fraction-wise. 10 over 6 becomes 5 over 4. 1 1/4 is what I was thinking that looked like. I was like, that's not right. So mathematically, I did catch I knew something wasn't right, but y'all caught my mistake. Thank you. Okay, before I identify my domain and range, okay, I hold this until last. Okay? I'm going to wait to do my domain and range until after. What are you confused about? I simplified 10 over 6. I divided by 2. Oh, that should be 5/3. Golly, y'all. I'm not going to cut myself slack on Wednesday. Good Lord. My bad. Okay? Am I right now? I'm so sorry. Look, if you're confused and it's my fault, y'all call me out. I promise you are not going to hurt my feelings, okay? All right, am I okay now? All right. I factored and simplified, and I found the coordinates of my whole. With trouble, but I did it. All right, the next thing that I want to do is I want to find my vertical asymptote. Now, yes, I can look at my graph, but I like to check myself with my algebraic expression, okay? If I take this x plus 3 that I have remaining right there, okay, and I solve for x, what does that give me for my vertical asymptote? -3. All right. Then I have my horizontal asymptote. I'm going to the original equation. Okay, so I'm going to the original equation, the one that I factored and simplified. And I'm looking at my exponents. Here, my highest exponent is a 2. And here, my exponent, my biggest exponent is a 2. So if my exponents are the same, I will divide coefficients. Okay? What are my coefficients here? 3 over 1, which gives me just that horizontal asymptote of y equals 3. Okay? Now, I am going to highlight all three of these things. Okay? And I'm actually going to come back up here to my graph, and I'm going to highlight all three of those things again. Because I want them to stand out to me, and I want them to help me identify my domain and range. Okay? All right. There are some things that are off limits. Okay? Right here, my domain, just a reminder, that's my X values. And I read those from left to right. Okay, I read those from left to right. Now, reading this graph from left to right, I have this little curvy part right here, and then I have this little curvy part down here. There is nothing that is off limits from the left to the right until I get to this vertical asymptote. Do you agree that nothing is crossing over that? It's actually converging to it. Okay? So right here, I'm going to say that X does not equal -3. And then I go to the other side of that asymptote, and the graph starts coming up until I get to the hole. Well, what is the X coordinate of the hole? +3. But then it keeps going on forever. So do you see from left to right, the two things that are off limits are these two numbers? Okay? So my domain is -infinity until I get to -3. And then I go from -3 to +3. And then I go from +3 to infinity. I am just leaving out the values that I just marked right here that I just said were off limits. They are off limits because of the vertical asymptotes and the holes. Okay? So, vertical asymptotes and holes affect my domain. Now my range, I know that these are my Y values. Yep. And I read my range from bottom to top. I read it from least to greatest. Okay? So I am looking at what Y cannot equal this time. So I'm looking at my graph, okay? I've got Y values that keep going down. So I know that I'm coming from -infinity, but then I'm affected by this hole, right? The Y value of the hole. So Y, careful, this is the one that it took me a hot minute to get. That was the 5/3. You're looking at that value right there. And then, what is this?
3.
Yeah, it's 3, but what is that? It's your horizontal asymptote. And that has 3. Okay? So your horizontal asymptote and your holes affect your range. Okay? So from bottom to top, I'm going to say that I go from -infinity to 5/3. From 5/3 to 3. And from 3 to infinity. Yes. Hold tight. Okay? All right. let's take a look right here, okay? And I've got some of these notations that I was looking at the other day, okay? Right here, this is as x approaches negative infinity, y approaches blank. This right here, this is my end behavior. We have seen this already, okay? This is the end behavior. As x approaches negative infinity, that's the left side of my graph. Brooke, sit up for me, baby. Okay? As x approaches positive infinity, that's the right side of my graph. So I'm going to look up here at my graph. As x approaches negative infinity, that's over here. Where are my y values? What are they getting closer and closer to? The horizontal asymptote, which is what number? 3. And as x approaches positive infinity, it's also approaching 3. So y approaches 3, y approaches 3. Okay? All right. Now, the next notation says, as x approaches negative 3 from the left, and this one says, as x approaches negative 3 from the right. Okay, well, here is negative 3. Okay, negative 3 is on my graph right here. Okay, I am looking at the left side. So as I'm coming in from the left, where are those y values pointing to? Where are the y values pointing? They're pointing up. What goes up? Positive infinity. And as x approaches 3 from the right, where is it going? Down. So from the left, it was pointed up. And on the right side, it was pointed down. Okay, you're looking at the arrows and where they're pointed. Okay? All right, next, I'm asked to look at as x approaches positive 3 from the left and as x approaches positive 3 from the right. Hey, where's positive 3, or what does positive 3 hold for this graph? The whole, right? So look right here. As x approaches positive 3 from the left, what are the y values getting closer and closer to?
Yeah, 3.
5/3. 5/3. Okay? And the same thing, as x approaches positive 3 from the right, what are those y values getting closer and closer to? 5/3. Y'all, there's a hole there, but remember, you can always add like one little more decimal, right? So it's infinitely going to approach the y value of that hole, which is 5/3. You are going to have to be very careful and make sure you're paying attention to what these are asking for. Now, these are all asking for the y values, okay? So for a hole, you should know that it's approaching the y value of that hole. Okay? All right, here we go. Let's look at before I do this one, I actually want to skip over here and I want to look at the next page. Okay? Because this is just going to take me through this process one more time. Okay? All right, the first step it asked me for is to factor the numerator and denominator and find the domain. I don't want to find the domain first, y'all. Okay, I'm gonna show you my order. The first thing I'm gonna do is I'm gonna factor it. I'm gonna factor and simplify. 2 times 3 is 6. Need it to add up and give you a -7. So you got 2x and 2x. What'd you say?
-6, -1.
Okay. That becomes 1 over -3. And 2 over -1 does not reduce. So I got x minus 3 times this 2x minus 1. And then this factors into x plus 3 and x minus 3. What simplifies? The x minus 3's. So my final simplified expression is 2x minus 1 over x plus 3. Okay? Now the first thing that I do is I find holes. And that comes from anything that canceled out. What canceled out was x minus 3. So your x coordinate is 3. We have to find the y coordinate. So I'm going to plug that 3 into my simplified equation. I'm going to try and do my math a little better this time, friends. All right, 2 times 3 is 6, and 6 minus 1 is 5, and 3 plus 3 is 6. Does that fraction reduce? No. Nothing else canceled out, so I'm done with holes. Okay? The next thing that I'm going to find are vertical asymptotes. That comes from what is left over in the denominator. That's x plus 3 equals 0. So what's the equation of that vertical line? X equals -3. Okay, I'm going to find my horizontal asymptote. Okay, we got 2 over 2. So my exponents are the same. Therefore, I will divide coefficients, and I get y equals 2. Okay, and then I'm going to find x-intercepts. Okay, now x-intercepts comes from what's left over in the numerator. So if I set 2x minus 1 equal to 0, what would my first step be in solving that? Add 1 and then, okay, so I'm going to write this as a coordinate that's 1/2 0. Is there anything left over right there? Or is there anything else that I need to set equal to 0? No. Now we haven't done this yet, but the next thing I'm going to do is I'm going to find my y-intercept. And this is where I plug in 0. Okay, but we plug it into the original. Equation. Okay? Now, what I want you to see right here is if I plug in a 0 into all of those x's, all of this is going to go away. And what I'm left with is just a positive 3 over a negative 9. Nobody should be on laptops right now, okay? My x-coordinate is 0, and my y-coordinate of the y-intercept is going to be negative 1/3. Okay? Because I reduced that fraction. All right. I have found everything that I need. Okay? I wrote this in lowest terms. I found the asymptotes and the holes. I found the intercepts. I'm now going to find the domain. I'm going to find the range also. And then I'm going to find the end behavior. Okay? So let's talk domain. What is it that we said affects the domain? From left to right, what would affect that? Do what? Holes and vertical asymptotes. Okay? So from least to greatest, if I were to graph this hole, just sketching it, right here I would have a hole at 3, 5, 6, which is almost 1. I would have a vertical asymptote at negative 3. Do I have any other vertical asymptotes or holes? No. Okay? So x cannot equal negative 3 or positive 3. That gives me a domain of negative infinity to negative 3. It goes from the left until I get to this asymptote. And then from the asymptote to the hole, right here, I go from negative 3 to 3. And then on the other side of that hole, it goes to infinity. Okay? What did we say affects the range? Horizontal asymptotes and holes. Horizontal asymptotes and holes. Now I already have the hole graphed, but the horizontal asymptote crossed the y-axis at 2. So from least to greatest, y cannot equal, let's see, the y-coordinate of the hole was 5/6, and then you have 2. So negative infinity to 5/6, 5/6 to 2, and 2 to infinity. I'm trying to give you references for things to look back at as you do this with other problems as well, okay? So you will know these are the things that affect the domain and range. Okay? Now, this is what I want to do, okay? I am going to type this into the graphing calculator for now, okay? You can type this into Desmos, but not right now. I just want you to look. Right here, I'm going back to my original equation, and I'm doing a fraction, and I type in the whole original function, okay? And all I'm going to do right here is I'm just going to sketch this on my graph, okay? So I know that I have a piece right here, And I know that this piece right here is going to be on either side of that hole. And I just got that from looking at the graph. Now, if I go into my table of values, I want you to watch this. If I go into my table of values, there's a couple of things that I want you to see. Right here, when x is -3, I have an error. Why is there what I would call an error right here? There's an asymptote. It's a vertical asymptote. That is where the denominator would be 0, which is off limits. Okay? And then I move over here to +3, and I have another error because that is where the hole is. Okay? So if you're looking on your Desmos, okay, or in a graphing calculator, you should be able to sketch the picture, okay, because the picture is going to help me with the end behavior. The end behavior, we will write the limit as x approaches -infinity, f of x approaches, and the limit as x approaches +infinity, f of x approaches. Jot that down, please. My end behavior, it's talking about the left and the right side of my graph. The further I move this way, the further I move that way. What values are those graphs approaching? What number is the left side of my graph getting closer and closer to? Careful. 2. Is getting closer and closer to 2. Okay? All right, I need for you to log into Desmos, not to Desmos. I need for you to log into Delta Math, and you are going to practice identifying these characteristics. Okay? Be sure and look at the due dates. Oh my gosh, yes.
Honestly, at that point, I'm not going to
Depends on how fast they make their potty trips. Okay? Log in. Quick. Y'all, please don't take your time. Log into Delta Math. Okay, full credit for this. Yep. Full credit on Thursday morning or Wednesday night at midnight. So you have all day tomorrow and you have all day Wednesday to do these questions, okay? All I'm asking you to do is identify holes, identify vertical asymptotes, intercepts, things like such.